Hello and welcome to the Jet Impact Lab for the Fluid Mechanics 1 course. The goal of this lab is to measure the force exerted by a jet of water on two different surfaces. As seen in class, the conservation of momentum equation will be used to predict the force of the jet of water. The apparatus, as shown on screen, has the following key components. A pump, located at the rear of the rig, is used to produce water flow for the experiment. The pump feeds up into the rig where it reaches a valve. This valve, when open, will let water flow into the nozzle. Adjusting the valve also enables us to control the flow rate of the system. The nozzle is located inside of a hollow cylinder and is pointed vertically directly at a flat plate. This flat plate is directly connected to a force balance which will be used to measure the force of the jet. Finally, water from the experiment will be collected in a tank used to measure the flow rate of the experiment. Here is a more detailed view of the force balance mechanism that can also be found in the lab manual. The plate shown here is the plate that will be impacted by the jet of water. The first step is to start moving the weight on the balance until the balance is level, and then recording the distance LW. A pin with a notch, as shown here, is used to indicate if the balance is level. A switch located behind the rig is turned on to power on the pump, and then the valve is used to bring flow into the nozzle and to regulate the flow rate. Observing the plate more closely, we can see that changing the flow rate has an effect on the sheet of water that is coming out from inside the cylinder. Once a flow rate has been determined, the mast is moved to level the force balance system. Its distance is then recorded. The final step is to determine the mass flow rate of the system. This is done by another balance tank located at the bottom of the rig. A lever is initially flipped in order to let the tank collect a certain amount of water. Once the tank has collected sufficient water, the balance will tip. At this point, a weight will be placed on the counter end and a timer will be started in order to record the time it takes for the balance to tip over again. Since we know the mass of the displaced water for a given amount of time, we can determine the flow rate of the system. The experiment will then be repeated again for a different flow rate. This means the valve will be turned in order to produce a different flow out of the nozzle. The mass will then have to be moved again and its distance recorded. After which, the mass flow rate using the counterweight system will need to be measured again. The procedure is then repeated again for a hemispherical cup instead of a flat plate. As we have changed the mass of the plate, we must then remeasure the distance Lw at equilibrium. The pump is turned on again, and the weight is adjusted until the mass balance system is level. Finally, similar to the flat plate part of the experiment, the mass flow rate of the system will need to be determined in the same way. And this concludes the video portion of the Jet Impact Lab.